This is unit number 3, video number 10, Lewis dot structures. We're going to look at drawing structures of compounds, structural formulas, and those structural formulas were designed in what we typically just call Lewis structures. Officially it's called Lewis dot structures because dots are used to represent the electrons. We're going to kind of combine that together. If the electrons are shared, we're going to draw a line. So Lewis used the concept of electronegativity and valence electrons and defined how the atoms are going to form compounds. That's what we're going to look at. Just want to remind about valence electrons. So here's our periodic table. And the number of valence electrons are going to be obvious on the periodic table. Now, we're not going to do any covalent bonding with the transition metals. A whole area of chemistry called inorganic chemistry. We look at that covalent and ionic bonding of transition metals. We're going to look at basically our what we call the main group, the 8 groups that don't include the d electrons or f electrons. So the number of valence electrons is just going to be a column number. So everything in this column has 1 valence electron. The core electrons are not involved in the bonding. Everything in the alkaline earth metals are going to have 2 valence electrons. We get over here to boron, carbon, nitrogen, oxygen, fluorine. We're going to have 3 valence electrons, 4, 5, 6, 7, and if we had something to noble gases, 8. So that's going to be critical because the bonds are going to form among the valence electrons, not from the core. So what we care about is the number of valence electrons that are present. Now, one of the general rules for drawing the structure is we're going to put the least electronegative element in the center. Okay? High electronegative elements like oxygen and the halogens, nitrogen, tend to be on the outside. Not always, definitely exceptions. It's not a hard and fast rule, but they tend to be on the outside. So, matter of fact, oxygen has lots of molecules where it's on the inside, but generally you're going to need something to tell you it's on the inside. Something in the compound or maybe instructions or something. Element like carbon is going to always be on the inside. Okay, so we're going to take a compound. Let's start out with methyl chloride, CH3Cl. Now, the way we're going to draw this least electronegative element in the center, but hydrogen does not want to be in the center. Hydrogen wants to form 1 bond. It wants 2 electrons. Because notice, hydrogen has 1 valence electron. It wants to be like its noble gas buddy, which is helium. So how does hydrogen become like helium? It gains 1 electron. Okay, so hydrogen only wants 1 electron. Well, a bond equals 2 electrons. Electrons pair up, they form a bond. So a covalent bond is 2 electrons. If we have 2 bonds, that's 4 electrons. 3 bonds, that's 6 electrons. Hard to do there. Okay, so we want to be aware of that. A bond represents 2 electrons. So if I take CH3Cl, we're going to write the hydrogens directly after the atom they're attached to. A couple exceptions like acids, but in general, we're going to write the hydrogens directly after. So this will be a carbon with 3 hydrogens. Then I'm going to bring the chlorine on because the hydrogen is not going to bridge atoms. So if the chlorine was down here, this would be incorrect because hydrogen cannot form 2 bonds. That's 4 electrons. It only wants 2. Now we know every other element wants an octet. We call that the octet rule. They're trying to achieve 8 electrons because the noble gases are the sp combination, which is 8 electrons. So carbon wants 8 electrons, and chlorine wants 8 electrons. First thing you want to do is add up the valence electrons. So we've got 4 valence electrons on carbon, 1 on hydrogen, 7 on chlorine. So 4, 7, and 7 is 14. So I have 14 electrons to draw my picture with. I must draw the picture with those 14 electrons. No more, no less. Okay? I've already drawn 2, 4, 6, 8. So I've already drawn 8 of those electrons. I have 6 electrons available to complete the octet. That's what's available for me to complete the octet. Now I'm going to ask the question, what do I need to complete the octet? Well, carbon currently has 2, 4, 6, 8 electrons. It has an octet. Chlorine has 2 electrons on it. It wants 6 more. So we say it needs 6 electrons. If what we have available is equal to what we need, then we dot it out with what we call lone pair electrons or unshared electrons. A lot of different terminologies for them, but that's going to be our unshared. These are shared. But we do them each electron individually, but obviously in pairs. Don't just dot out 6 electrons. 2, 2, 2. Okay? Now, we can do another compound. Let's say CH3CHO. Call this acetaldehyde. We do this compound here. Now you'd say it's a lot of atoms. It is, but we know the rules. Least electronegative elements in the center. Hydrogen never bridges atoms. So these 3 hydrogens must be on the carbon. This hydrogen must be on the carbon, because we write the hydrogen directly after the atom it's attached to. So it's going to be C with 3 hydrogens. Now, where's this carbon going to be? Well, it's not going to be bridging off one of these hydrogens, because that would give it 4 electrons. Hydrogen only wants 2 electrons. So I'm going to put my carbon here. We know the carbon has a hydrogen attached to it, and it has an oxygen attached to it. Now I'm going to add up the valence electrons. Carbon has 4, oxygen 6, hydrogen 1. 4, 5, 6, 7, 11, 12, 18. So I have 18 electrons in the valence, meaning my picture when I'm done must have 18 electrons. No more, no less. And we want everything to have an octet, except for hydrogen. I mean, hydrogen just wants to have 2. I've already drawn 2, 4, 6, 8, 10, 12. Subtract that off. That tells me the number of electrons available to complete the octets. Now I'm asking, how many do I need? Well, this carbon has 2, 4, 6, 8. It's happy. This carbon has 2, 4, 6. It needs 2 more. This oxygen has 2. It needs 6 more. 2 plus 6 is 8. So we need 8 electrons. We have 6 electrons. The difference is 2 electrons. Whatever that difference is, you're going to add in bonds. Each bond is 2 electrons. So this isn't add 2 bonds, it's add 1 bond. I can't add that bond here. If I do, I expand the octet on the carbon. Carbon never expands an octet. So I'm going to drop this right here. That's 2 of my 6. Add the other ones. And now I should have drawn 18 electrons. With a big molecule like this, you want to check and make sure. 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. So in summary, drawing Lewis dot structures, you need to determine how many electrons are available. Get your backbone structure set. Least electronegative elements in the center. High electronegative elements like oxygen and chlorine tend to be on the outside. Then remember, hydrogen is written directly after the atoms they're attached to, and they only attach to 1 atom, 2 electrons on a hydrogen. Then figure out how many electrons are available in those valence set to complete the octets. If there's not enough, we add bonds. If there's enough, we add just lone pairs of electrons.